So today I'm here to talk about SQL generation use case. Just a quick brief, this use case has been done with a client and Google. And I have to say they are going into production with it. And it's an exciting use case because it's a real life use cases. So what's going on? So generative AI with data streaming with Confluent. Why is it important? Why do we think like Confluent can bring a lot of like good things into your generative AI story? One of the things is Gen AI is as good as your data, right? More your data are fresh and of quality, better the outcome of your generative AI will be good, right? You increase less hallucination. You have more like accurate data as your flow of information is coming in. And your data with Confluent is available as it happen, right? So you have in Confluent, I don't know, for people that doesn't know, we have tons of connectors that bringing data in real time from different sources. It can be database, but it can be also systems like IoT and things like that. So what did we do? Why did we use Confluent and to generate SQL generation? One of the pain points that this company had is to make their data available to staff and also customer that doesn't have any knowledge of SQL. And one of the challenges is like, how do you index, for example, your data catalog, and how can you leverage generative AI to generate those SQL query to bring back information to our customers and or to the staff. One of the interesting things that we use for Confluent is your prompt testing. So for everybody that's doing generative AI, we understand that the prompt is something very important into the generative AI. Without a good prompt, we don't get a good outcome. One of the things I did when I developed this solution was really doing a lot of testing to check the quality of my prompt and being able to replay. And one of the capabilities of Confluent platform is to replay replay your events. So I was able to have a good set of questions that I was asking to my generative AI. And by updating the prompt, I was replaying the entire set of like question I wanted to ask. And I was able to compare like the result and pick the best prompt that I could come with. The interesting part is because we have the data coming into real time and saved into BigQuery, I was able to have the fresh data as it goes. So the use case, for example, we were having is to be able to get like the healthcare provider within a certain radius of your location. And that was very interesting because we were able to add, for example, a new healthcare provider and a new client coming in and said like, hey, where is the closest healthcare provider in my area? And then we had Gemini that creating the SQL query properly. We were doing the query into BigQuery and send that back to, again, Gemini to create like a summary of those data so we can give like a concise, very nicely summarized response to the customer. So what's the challenges we had? One of the challenges we had is how to describe the schema of your database, right? So we can't, in generative AI, we cannot just give a schema without explanation of what those fields are about, right? And to get like a really, really good outcome with Gemini, we ended up by giving the schema of each table that was in our database, right? And each field had a business description of what does that mean in plain English, right? That's the best things, like it's like, and that was like part of like creating the prompt and do the A/B testing, because like sometimes the explanation of the field was not good enough. So that's something we need to like iterate throughout the life cycle of your development. The fact that we were able to have fresh data was giving us like a better outcome, and we didn't have any hallucination. So like even if, like, for example, two tables were not joined, for example, by like a join, like the Gemini was able to give us a proper query. And one interesting thing is that I was very excited about is the geolocation, right? So I didn't know that Gemini will be able to handle geolocation. But it worked really well. I was like very amazed where someone started to, we asked like a 5 minutes driving distance, right? And we in the prompt, we gave some parameter like we assume a car is driving at 10 miles an hour, for example, right? So he was able to like create the proper SQL query with the proper math. So we were able to get the right service provider within the location. That was really, really, really interesting. And the rightness of the SQL required us, for example, into the Gemini is to give example of the outcome. So it's very important into when you design your prompt, is to explain what your outcome, so you get what you need, right? So we give example of what we were looking for, and then Gemini was able to fulfill what we were asking. One of the interesting things is, I always said, is talk to your LLM the same way you're gonna say talk to your 5-year-old kid. It's very important to explain exactly what you're looking for to get a best result and to avoid hallucination. I do that with my son and it works really well. So here is like the architecture, the overall architecture, what we've done. So we did two flavors. One was a voice to SQL, and the other one we were able to leverage the API that we were exposing for the voice to do like a pure chat type chatbot, right? So the way it works, everything is going through topics. So everything is real time. When we speak, we had an API that's getting like your voice, that's put that into a topic, and that's get transformed into a text. That's when sent then to, so when you see here, when then sent to the text request, which goes through a Flink. So our Flink AI is able to go and talk to Gemini and say, hey, Gemini, here is what the human is looking for. Can you just give me the SQL that corresponding? Then when we get that, we go to a microservice that was doing the query and push the result into another topic. And then we had another Flink job where this Flink job were taking mostly this table of data and ask Gemini, hey, can you give me a clear summary of that data so we can send it back as a voice to the human, right? And that was very interesting. The interesting part is the slowest part was doing a speech to text, but outside of that is very, very quick, and we got the answer in a very few seconds. We got the answer and we were able to fulfill the use case. One of the other aspects of the use case, which was this one, is leveraging an API. So that was more for the business people from the company that looking, for example, one of the things we had into our data, sample data, is like application, right? So let's say, and it's applicable for any type of businesses. Let's say you have a contract that it's stale because it's missing some documents. And that's exactly what happens. We had an API with a chatbot, which was like, hey, can you give me all the applications that are stale because of certain condition? And what happens is, like, obviously Gemini was able to give me the SQL query that matching what we need, and we were sending the result back to the business person that was able to act. One of the interesting aspect on that is the business person doesn't need, in this case, to know SQL, or doesn't need even to know if the data exists in some way, right? They really talk to the system as your entire company or your entire business could make all the data available to your generative AI, and then anyone in the company that's looking for information to increase the business at the end of the day, right? To make the experience for your end users much better, what you do, you expose those data to the business person that they can interrogate your database without knowing even if the data exists or even any knowledge into SQL. The conclusion of all that, at the end of the day, we try to make our business better, to make our business more successful. And we try to also increase the quality of the service we are providing to our end user. So by bringing the data together into one place, by bringing the data in real time into one place, that's allowing you to increase the quality of your generative AI, and that's allowing you to literally give back like the quality of service that every customer in every single business deserve at some point. And also that's opening some doors from the staff within the company to explore new data that they were not able to even know about before, because just by using natural language. And obviously all that is scalable, right? By the nature of if you're familiar with microservices architecture, and especially event-driven microservices architecture, that's allowing you to scale based on the complexity of your microservices. When you look at this architecture, for example, and go back to the previous one, every single boxes you have is a microservice in some way. So you can scale them based on the complexity of the task for that microservices. And, oh, sorry, a wrong slide. So I'm going to talk a little bit about Flink inference. What's Flink? Maybe it's a processing system that allows you to process data in real time. It's a fully managed service, and it's on top of that of using a very simple language, because Flink and the managed service that we have at Confluent Cloud is leveraging SQL. So lots of people knows SQL. On top of that, you are able to call your remote inference within Flink. So as the data comes in, you are able to call your LLM or call your embedding, for example. So you can just generate your embeddings and then index that into a vector database, or just call your LLM to create like summary and things like that, right? The interesting part, it's a very simple. I will show you some few query so you will understand what I'm talking about. And on top of that, it's working on up-to-date data, which allowing you to make decisions very fast. One of the things that's interesting is there is a lot of talk about workflow, LLM-based workflow, right? So you could have some data coming in, ask an LLM, can you give me the sentiment for that, for example, TikTok post, whatever it is, right? And then based on this sentiment, you can do decision within the platform to use different prompts or to do some more processing. So here is an example, few examples of the Flink query. So the first things when you want to use Flink AI is you have to create a connection between the Flink instance, obviously, and your LLM provider. So in this case, we have GCP here. And the things that is done because we don't want to expose the API key. So it's a command line tool that you can do into your CI/CD pipeline. And then you can give the API keys, and then it's sent to a Confluent platform. At the end, the one in the middle, so that connection is just mostly a wire between the Flink AI and you have Gemini, for example, right? And then you can create models. So connection are reusable between models, right? So in this case, for example, in that example, we have a Gemini model, and we send a text as an input, and we expect a response as a string, right? So it's a string. So the interesting part is you have parameters that you can change. So you can create different model with different top K, top P, but also there is some system prompt, which is a default prompt that will be used all the time when you use that model, right? And you can create multiple models for the same connection. And then what's happening is when you have done that, it's just a question of calling it. And the way you call your model is by using a function called ML predict. And that's taking parameters, obviously. And the model name is one of the parameters, and also the user request. And you can also dynamically add some parameters based on the payload. Like, for example, if your request has multiple fields, you can use those field value into your system prompt to make sure that it is like more, it's dynamic, right? So one of the example I did in the past is I had my client file into Kafka, right? Into Confluent Cloud. And what I did is, like, when the user is authenticated, I was changing the prompt to give the first name and last name to the LLM, and that allowed to be more personable, right? So the LLM was like, hey, hi, Pascal, how are you doing today? And while you are not authenticated, the prompt was different, right? So why Flink inference? In general, Flink is very cost efficient. It's cheaper to run you don't have infrastructure cost, right? It's baked into the Confluent Cloud subscription. And at the same time, it scale as it needs, right? So you don't have to worry about is my process going to scale, and also need to have a team to make sure that things are up and running. This is done by the managed service. It's obviously real-time processing, like we've been talking about that a lot. It is real-time. It is as the data comes in. And you can have so many, like, multiple source of data. You can join them and you can use them to have like a much better experience. It's integrating with obviously AI ML, but because of our ecosystem around Flink that allow you to bring like data from different sources like SAP and those kind of like bigger system, like big system. And we have also a lot of connectors for like a BigQuery and things like that. It scale automatically, like I said. SQL is very simple. Like most of people, and especially in the software engineering world, a lot of people know SQL, and it's a very simple language to learn, and you can just develop your LLM integration in like few minutes. It's because it's fast, it's low latency, it's fault tolerant, like I said, and it's allowing you to like bring the data and the ecosystem integration, like I said, about all the connectors. So if you want to try, don't miss this opportunity to simplify your data streaming. You can scan the QR code and you will get $1,000 worth of free credit to play with Confluent Cloud on a Google Marketplace. And now I'm going to just go and look at the question. Alors, is there a link to Flink AI? So what's going on is if you scan this QR code, you can sign up and you will have access to Flink AI right out of the box. Anything which can be shared while creating the API for Flink Inference for cost, infrastructure, scalability, perspective, and for end customer. So yes, I can share some link. Like I need 1 minute to get all the link, and I will give that to you. But we have like on our website all the information about Flink AI and the scalability and some technical information about it. How complex the SQL script the system can generate? Most of the time, the non-technical person does not necessarily does not know how to write simple SQL. But like the complexity, I was myself very impressed about Gemini. Like I said, I was not expecting to have, for example, geolocation. And the database at that time, so we are moving to BigQuery, but at that time we did a test with Postgres with PG vector, and it was very interesting. PG location, the plugin for Postgres, and I was like, Gemini is never going to generate a geolocation, but it works really well. And I didn't describe any joins into my tables, and he was able to give me the proper join in between like two tables to find the proper information. So I was like, I have to say, I was really, really impressed about like the quality and the complexity of the SQL generated by Gemini. I will highly. Interesting. We are going to create a quick start soon that you guys will be able to download. It's not done yet because it's a work in progress, but like everybody will be able to access it and play with it. And I have to say, you will be amazed how good it is. Yes, and yes. And that's what I've been tested, right? So it's not like, obviously my test is limited, and like if I were like I'm not implementing this POC into production for the client because it's another team that do that. But I would like have an exhausted test to make sure that we cover every single use case. Well, sorry, I need to scroll. Sorry. What would be the recommendation to use system to drive big data system, since it can be out of hand sometimes in terms of cost when running inference on each query and connecting to Gemini for each row? That's interesting. Yes. If you have a lot of data movement, it can cost a lot of money. That's very sure. That's very true. It depends of your use case, to be honest. Like that question is very open, because what you could do is to accumulate data and have like a kind of like micro batch type behavior, right? So where you can accumulate and send that to your LLM. Let's say you want to summarize a list of products, right? So you have products coming in into your pipes, and you can try to accumulate like, for example, a few products and send that to Gemini and say, hey, Gemini, can you just like summarize those 10 products? And then he's going to give you a summary. Don't forget to explain Gemini what's the outcome you're looking for, the example of the payload you're looking for, and then that should work. It's really depend of your use case. Like if I would love to know more if you have like an idea of like your use case in mind, and then we can easily like talk to each other on that. Is there an open source plugin on top of Flink which provides similar features? No, not on top of the managed Flink we have. For the self-managed Flink, I'm not sure about, but the one we have is a managed service that the only thing we coming up with right now is UDF. So you will be able to create your own function and upload your it's going to be jar or a Python module into Confluent Lab to expose that UDF. But right now there is no open source project around that yet. The geolocation, to be honest, I feel does not reflect the complexity of the SQL generation capabilities. But yeah, okay, it's a fair assessment. But it's like I said, I was not my expectation. I was very like all the example of SQL generation I've seen so far was very simple, and like I found it quite interesting that he was able to do that the proper geolog for the right database, because database it's slightly different. So I was very I was amazed that it works, and the join worked without even explaining. Like I should have copy paste into the presentation the prompt. But the interesting part is like the Gemini was able to just like do the joins properly because I had like the proper description into my field, right? What I'm trying to explain is like the description for every single field is where you really need to pay attention, and that's the only way you like. I think without that, you like Gemini won't be able to do the proper job. That makes sense. Good. Any other question? Yara, I think it's back at you. Thank you very much.
Thank you, Pascal, for your time. You still will be backstage, probably during the Q&A. You can come back, and in case there will be some additional questions, but that was a great help and insightful information. So our second speaker for today is Slavinigam, and let's welcome him to the stage. And here we have. Enjoy.
Thank you. Thank you, Pascal. Very interesting session. And I hope all of you are enjoying that. So a bit about my session. So initially, the topic was slightly different. I was thinking of doing more of a function calling and agents and all of that. But as all of you are aware, and if not, this will be a good session for you to be aware that we have recently launched Gemini 2.0 Flash. So I thought, why not sort of talk about that, show you how to use that specifically. We have great assets that we have recently published. So I want to show you in fact, three things. One is the unified SDK that we just launched, and what's the benefit of that. The second is how do you use the SDK to play with Gemini 2.0 Flash right away? So it's available to all of you. It's free, and you can sort of just play with this on the cloud as well as on the Google AI Studio side. And the third one, which is the most interesting and the one which has been making a lot of rounds, is the multimodal live API, right? So I'm going to show you all three of these things as we proceed. And I'm going to share, of course, all the links that I'm going to talk about. So the first link that you see here, in fact, let me quickly right away go ahead and share this link so that you know what is the link that I'm following, and you can just open it up and just follow along with me. You can maybe do this later and just see what I'm trying to do. So I'll keep sharing the links as well. Okay, let's get right into it. And just a quick thing, I might switch off my camera because I'm having some issues with the internet. So at least my audio and the screen should be visible. So I'll just take that as a precaution, and I'm just gonna quickly switch off. All right. Okay, let's start. So the first thing is we're going to talk about the unified SDK and the Gemini 2.0 Flash, and how do we use this with the unified SDK. The way to run this notebook is, again, you have three options essentially. One is you can actually open this in Colab, which is what I'm going to show you. And you can see this is the one that I'm currently running. The other two options are you can also open this notebook in Colab and also in the Vertex AI workbench. And I've just opened it up and I just ran it before the session, just so that we don't get into any last minute issues and all. So I'm going to talk about quickly the very first thing that we introduced. So again, some of you who have done any kind of development with Gemini 1.5 Pro and Flash before, you might remember that we used to use a different SDK, and that SDK is not going anywhere. That SDK still exists, but this is a new SDK, which is the Google Gen AI SDK. The beauty of this SDK, and there are many things which are good, but I'm going to just highlight the one which is one of my favorite and will work wonderfully well with most of you, is the fact that now we have integrated and unified both the Google AI side of the SDK as well as the Vertex AI side of the SDK. What that means is that you can now very well run the same notebook and the same SDK in both the open Google side of the thing, so which is the Google AI Studio. So if you're like, I don't want to do anything cloud, I don't want to set up any project ID or any of those things, you can still use the same code, and you just change one simple thing and everything sort of just works out of the box for you. So that's the beauty of unified SDK, because now you can sort of experiment in either of the platform. And of course, cloud has all the security features and all of the other things which you would want. So of course, if you're trying to build something on your customers' data or some internal data, you would prefer doing this on maybe cloud, because you'll have cloud storage and your data sets might be in those locations. So now it wouldn't require you to sort of suddenly change a lot of things. So that's the benefit of unified SDK. Again, there are many other things, but I'm sort of just highlighting the ones which are important for us. So we start off by sort of simply installing the SDK, which is called Google Gen AI. So you can just do a pip install right away, and you should be able to get that. The second step is doing the authentication. Authentication is important if you are trying to do this in, let's say, Google Cloud. If you're trying to run this notebook as a Google Cloud, you would want to do an authentication so that the project ID details and all that you will put later in the client will be authenticated, and you should be able to sort of run inside your project ID. Once you do the authentication, we're going to import bunch of things. This time also you will notice that we are importing from Google. We import GenAI, and then all the methods are available inside that. Next, again, because we are doing this on Google Cloud, you will notice that we are setting up our project. So you can see that I've added my project ID. You'll not be able to do that because this is a project that I have at my end. In the link that I shared, you will notice that there are actually no project. So it tells you to add your own project. So you would have to do your own project at this point. You can change the region as well. So if you are in Europe, if you are in Asia, we have regions available for our models. You can check the documentation for that, and then you can set those things accordingly. And then all you have to do is just initiate the client. So this is where I say GenAI.client, I say Vertex AI true, and then I pass my project ID and location. And at this point, this is where you can actually change the client. You can say, hey, I don't want to do the cloud experimentation. I actually want to do this on the Google AI Studio side of things, right? Which is sort of not linked to cloud at all. So if you are planning to do this, then you do not need to do any authentication. You do not need to do any project ID. You do not need a cloud account. All you need is an API key, which you can get from Google AI Studio. So again, for those of you who know, you may know how to get this API key. For those of you who are hearing it for the first time, all I will say is that just search for Google AI Studio, and then you'll get all the things inside that. You'll get the API key and all of those things inside that, right? So that's the only change that you need to do. Again, you can build complex softwares and everything, but what I'm going to walk you through is different features of the SDKs and the things that you can do. So as long as you know which client you're trying to run on, you can just make that change at the top, and then whichever client you end up choosing, you'll be able to do that. I am in this case using the client which is the cloud one, so that's what I'm going to use, right? The next one is I define the model. So you can see that I'm defining the Gemini 2.0 Flash experiment. It is still experiment because this is not GA'd right now. This is still a public preview, which means that, be careful while running the model. And what is that? Whatever you're trying to send, you might see some quota issues. You might see some issues in terms of resource exhaust errors and all of that. That's all expected because there are lot and millions of people who are accessing it. So sometimes the models are down. So that's why we call it as experiment model. In the same unified SDK, it's not that you can only access Gemini 2.0. You can actually just put the 1.5 Pro as well, or 1.5 Flash as well. So you can actually use the older models as well, not just the 2.0 Flash. Now, once we've done that, we've done a basic setup. A very simple way to call a simple generate content. And you can see that because of the unified SDK, there are a lot of sort of simplification of the methods and the types and all of those that has happened. So because we're using clients, so you can see that the client is still the main class that we are always calling after the initialization. So that's why even if you were to use cloud or the Google AI Studio one, you will still do everything else as it is, right? So you have the client, you call the models, and you do the generate content. You define which model you're trying to access, which we have defined here. And then you simply pass the prompt in the content. So you can see that I'm actually calling this by saying what's the largest planet in our solar system. And then it says this is Jupiter. And I'm sort of displaying this as a markdown. You can see that Jupiter comes out to be bold. You can just do a simple print as well, right? Either way is fine. So this is the very simple way of sort of using the model, which is you just send any prompt and then you just get the output by defining the model that you have. So that's the most simplest way of using Gemini 2.0 Flash. Now, of course, you have the UI as well, which is the Vertex AI Studio. If you want to do this inside cloud on your data, you have the same model available there. You also have Flash 2.0 experiment model available on Google AI Studio. So there also you can sort of use this in the UI as well. This is again heavily focused on the SDK part. So if you're trying to build something, experiment something, this is how you can sort of do this. Now, what I'm going to show you in next couple of blocks are the different features which are available as part of the SDK and specifically Gemini 2.0 Flash, right? So the second one is the content stream. So again, you may know that a lot of times you maybe do not want to sort of generate the whole thing in a single go. Maybe there's something that you have asked which is slightly bigger. So, for example, tell me a story about a lonely robot who finds friendship in a most unexpected places. So you can imagine that this is not going to be like a very short answer, just like the previous example. So a good way to sort of address this is that you can actually generate this as a stream, and because we have to collect the stream, we are running a for loop here, and that's why when I let me see if I can run this. So if I run, you can see that it sort of gives you step by step. And again, you might see a certain latency because we are still sort of doing this as a for loop. But when you actually put this outside, integrate this in the any web frameworks or so, you'll see that answer coming like step by step, just like you see on Gemini when you ask a question or something like that. So this is another method that you have, which is rather than doing generate content, you just say generate content underscore stream, and then everything else sort of works as is. Now, so we have seen the two methods which are doing simple generation and stream generation. The third one is the chat. So you can also do a multi-turn chat. The way to do that is, again, you use the client and you define a chat session by passing the model. So you define the chat object. So this is your chat. And again, you can name it anything. You can say this is my chat number one, or say chat one, or something like that. So once you have the object of the session defined for this chat, this is the session which will hold that memory of the whole chat that you're doing, right? So for example, now I can send in this object, I can send a message saying, hey, write a function that checks if a year is a leap year, right? So you don't have to mention that, write a Python function or so, because by default, it will give you a Python function, but you can mention saying write a function in C++ that checks if a year is a leap year. And then you can very simply display the text. You can see that we are getting a very proper formatted text along with the explanations of each and every line. And it's really fast. Like if I were to run this and just to show you how fast this is, you'll get the idea that, it's not something that takes a lot of time to generate so much of the content, right? And of course, you have the streaming function, so you can always stream these things as well. Because this is a chat session and this is a multi-turn chat, what you can also do is you can send another message where you do not define what you did in the previous step and what the answer is, but you can just extend the session. So you can say, hey, write a unit test of the generated function. So because it has this in the memory and you're still using the same object, what this does is it sort of helps you, it helps you sort of ask the same question to the previous question and answer that you have. And you can see that now the next step it does is when it runs, let me actually run this. This will sort of generate the unit test of the function that we have written just before, right? So you can see that it wrote a couple of tests and it sort of defines the unit test as well. Again, this is a very simple example. You can, of course, get more complicated. You can define more instructions saying, hey, I need this to be part of the test cases. I want the edge cases to be part of the test cases, and so on and so forth. The outputs are really interesting. What you will notice, and this is something we also mentioned during the launch, that in many cases you will notice that Gemini 2.0 Flash is very similar in terms of the outputs to Gemini 1.5 Pro. So if you have been using Gemini 1.5 Pro, you will see very similar generations with the 2.0 Flash, with of course the faster outputs with the same token limit, which is the 2 million tokens that we can expect. So you have pretty much similar behaviors, but fraction of the latency that you expect from Flash versus the Pro. So this is one. The next option that you have is doing the async, which is the asynchronous request. And again, there are many times where you don't have sort of sequential steps and you're like, hey, I just want to run this, but all of this has to sort of just go asynchronously, right? It doesn't have to sort of do one step after the other. They are not sequential in that nature. So in those aspects as well, you can actually use async models, and just a very simple change that happens is rather than saying client.models or generate content, you can just add AIO, which defines that now you're running the same thing, but this time you're essentially doing this asynchronously. What you need to add is the await, because again, if you were to sort of do this async, you need to wait for all the things to get collected back, so that you can then finally do the print. So this is exactly what is happening. So whenever you're using the async option, make sure that you're await await option here, and you should also be aware that it behaves differently when you try to do this on notebooks versus when you would want to do this in, let's say, any web framework or things like that. So this is the second option. The other thing that you can do is, this is how you would define the configuration. So now we have made it very simple for you to define all the configuration inside the type, which is the generate content config. So your temperature, top P, top K, all of this are can be defined here. In this also you have the system instruction, so it's the same generate config, and you can define the system instructions as well. So the interface have become a much simpler now. And again, do remember that all that you're trying to do, you can actually run it on both the ecosystem, right? So you can run the same notebook just by changing the client in the Google AI ecosystem, and then the same notebook you'll be able to run in the Vertex AI ecosystem. But again, I leave it to you to know and decide where should you be running this, right? If you're using any data which is sort of crucial, which requires privacy, you would prefer doing this on the Vertex side. But if you're just experimenting few things, you're trying to figure out certain proof of concepts where it doesn't require any data, you may be faster to do this on Google AI, because you don't need to set up any cloud or things like that. But be aware, there are restrictions in terms of the quotas and in terms of requests per minutes and all of those, which are very different in cloud versus the Google AI. So be aware of those things, and you can see all the details of the RPMs, like the request per minute that you can send, and the quotas that you have when you initially start doing all of this on the documentation. So you'll see all of those details there. The other thing which generate config has is the safety settings. This is again, some of you again who are using who have been using Gemini models, you would know how safety settings are very important, because you may want to sort of control the behavior of the outputs that are coming, right? So you have that control with you, and you can mention those controls inside the safety settings, where you can define whether some things are to be blocked or not blocked. Do remember, and this holds true with Unified SDK and Gemini 2 as well, that there are certain things which are still blocked, even if you were to say that do not block anything, because those are very foundational filters. There are certain things that we do not allow as a company to work. And of course, if you have a use case around it, you can always reach out to Cloud and say, hey, I have a use case and you guys are blocking it. And we would be happy to sort of help you and support you on that. But still, at a very high level, you have these different controls where you can actually set this up. This is also very important sometimes when you're trying to put your, let's say, product out in the market, or product out in the hands of the users. You may want to still control what people are sending to you and what they're getting out of it. So you can control that as well through the safety settings. Again, like I said, safety settings are part of your generate config. So you can just define that and pass it in the same generate config. The best part is, if you still want to sort of, once you generate the text, you can print the safety ratings of the output. So it will tell you what exactly has been blocked or not blocked, so that you can you can control that. So if you see the prompt here, I'm actually writing a very nasty prompt saying, write a list of 5 hateful, mean, and disrespectful thing that I might say to universe after submitting my toe in the dark. So you can see, like, this is, again, this is not too controversial, but just an example to show that because you have put the threshold of block low and above, it has blocked some of the things, and it tells you exactly the probability score and the severity score of it for you to sort of address that if you have anything. Um, Now, the next thing, and this is very important from a Google Cloud perspective, is that what if I want to send my data? Because again, Gemini is multimodal. So we keep the same thing with Gemini 2.0 Flash, that you can send your images, you can send your PDFs, text, videos, and all of that, right? So we still maintain the same thing with 2.0 Flash, which means you can actually send all the data that is sitting on GCS or on the local and all of those things, right? And this is what mentions, this whole table sort of mentions what are the different file types that we expect, right? So we sort of read text plain, we read application PDF files, we read three different kinds of images, we read multiple kinds of audio. So you can define any audios that you have, and you can just define the MIME type of it. Same with the videos, you can see that we sort of support many different kinds of videos. And just to show you an example, I'm downloading a simple PNG from cloud storage. This is again a simple file of image, and I'm opening this up as a local file. I'll show you an example where you can actually pass this URI as is in the prompt, and then just ask the model to generate something. But this is, I'm showing that you can actually load the local file. So I'm loading this image file, and then I'm passing this in the part object. Again, this is very similar to how we used to do previously. So we're just copying the same thing. So you say part dot from bytes because you're not doing from URI, and then you pass the image object, and then you define that image as image slash PNG. And then you say write a short and engaging blog post based on this picture. So you can see that it sort of goes and it understands the images, and then it sort of gives you up all of those things. Now, same thing. Let's say if you're like, hey, I don't want to load anything from local. I want to pass a GCS file, a file which has been sitting in the GCS bucket. Now, do remember that in GCS there are some files which are available to everyone. So if you have the link of GCS URI and it is made public, everybody can access that. Just like in this example, this particular one is made public, so that's why we are able to run it. However, if there are files which are only allowed by a specific project ID and you have authenticated with that project ID in this notebook, then you will only be able to access that. And that's the beauty of GCS integration, right? That's why you would not be able to do everything in the Google AI system, and this is the kind of things you would want to do in the cloud because of the security. So let's say, imagine that this is the file which is not made public, and this is something internal, and there's a PDF, and I just want to summarize it, right? So you don't have to then download or do anything. You can just define the GS URI, and it'll take care of loading that up, sending to the model, and all of that. Most importantly is the MIME type. So whatever is that you're passing. So because I'm passing a PDF, I need to define application PDF in it. And simply I'm just mentioning that, hey, this is summarize the content, and you can see that it sort of does the whole summarization quickly without sort of spending too much time. Same example, you can see I'm passing a URL. So you can see that I'm actually passing a internet URL, not a GCS URI. And it's an MP3 file. So I'm changing the MIME type, and I'm saying write a summary of this episode. So you can again see that it went ahead, downloaded, sent this to model, and model is able to do that. The one new thing which has come up, and this is very interesting, this is something which is very personal to me, and I love this feature, is the integration of YouTube. So now what you can do is, in the same file URI, you can actually pass the YouTube link. Let's say there's a YouTube video and you're like, hey, I want to summarize this, or you have some specific questions about it, about the video. Let's say you're watching a series or some tutorial, and you have some questions that you want to get answered. You don't have to now download anything. You can just mention the YouTube URI, URL, and then you can just define this to be a video MP3, and then you can ask very specific questions. You can say, at what point in the video is Harry Potter shown? And it sort of takes a lot of time because it has to do the downloading in the back, and sort of sending this to the model. So this takes time. However, it tells you that, hey, it looks like at 56 second up until 1 Harry Potter is shown. And for just to show you this example, I was actually testing this just to see whether it was giving. You can see very clearly that exactly at 56 and 57, it actually starts and this is a Google 25 years in search video. All of you can check, you can run this on your own just to see, how this works. And it actually runs till 1 minute. And you can see that these are all the YouTube, all the Harry Potter things. It was able to pick up from the huge video it is. And mind you, if you actually play this video, you'll see that how this video is, has so many things going on in this video. It's not like one thing or two thing. It's like thousands of things going in this video, and the model was able to figure exactly that and tell you the timestamp of those things. Now, I'll come to the multimodal live API in a moment, but just want to quickly share the other things that you can do. So you can actually do pedantic data generation. So you can control the generated output. So you can define a simple schema using a data class using pedantic, and you can say, and you can tell the model that, hey, I want the response to be application JSON, and this is the schema that you need to follow. So you can either pass the schema as pedantic data class, or you can actually pass the schema as open API, not open AI, but open API format, right? So this is the open API format of schema, where you can define more complex structures. So one way to think about this is, if you have a simple data model where it's not too nested and it's not too complex, pedantic works brilliantly well. You can just get everything exactly in the way that you've defined. If you have something very nested, and a lot of times we have some things that we are trying to put a structure around when the model generates, then use the open API format, which is this, where you exactly define what is each and every entity, and you can also define the required ones, the one which model needs to do. And then again, you do this and it will follow exactly the structure that you have given, um, in order to sort of give you the output. Now, quickly, a few things. You can also count the tokens. You can compute the tokens, so it sort of gives you all the tokens and the count tokens and all. The other very, very interesting feature is that now you have Google Search as a tool, and this is what the Gemini 2.0 agentic part of things are, right? Now, there are many times where you want to ask a question to Gemini where it may not be part of the training data, right? So things like, when is the next total solar eclipse in United States? And you may want to use Google search for it, right? So it should be able to do a Google search, figure from that, and give you the answer. And now you can. And if you notice a very simple change that we need to do, first is you need to define the tool. So you just define a tool, and then you define Google search. You initialize that tool, and then in the config, in the same generate config that we were seeing, you can just pass this tool saying, hey, whatever prompt I'm giving, make sure that you use Google search tool, which we have initialized, to give the answer. The most beautiful aspect of this is that not only does it give you the answer, which you can see here, but it also gives you the grounding chunks, which means it tells you exactly from where it is picking up this answer. In fact, if I click on this, hopefully this opens, you can see that it actually picked up a Wikipedia link from where it is picking up the answer. So this is brilliant, right? Like, this is exactly what you want sometimes when you're asking a very factual question, that it should go search Google and get you the answer, and also give you the reason, give you the URL of what it is. It also supports vector AI search. Again, I'll not spend too much time. If you know what Vertex AI search is, you know what it is, but you can actually define your own data sets and everything inside Vertex AI search, and then just use it as a Google search. So just like Google search is doing the world search, you can put your own data sets, company's data set, in a secure environment, and then pass that as an input for the search. So it's almost like doing RAG, just by doing simple setting up of data store. Just the two examples of function calling. So 2.0 Flash also supports function calling. So you define your function, whatever that function is, you define the schema of the function, make sure that you define the proper structure, what is expected as input, what is expected as output, what's happening inside the function. And then again, in the tools, you can simply define that function. So let's say your function does something, right? It's hitting some API, getting you the answer. And it could be any API. Let's say this is a weather API that you have written inside this function. You can again just pass it to the model and say, hey, what's the weather like in Boston? And it should be able to hit the API, get you the answer, so that you again get the very grounded answer. This also supports the open API specification, just like we were saying the generation in the control generation part, which means you can also define the parameters of what the function should be calling, which is to say that rather than execution, this focuses on building a signature or a API signature that will then be used to execute the specific function that you want to do. So both of them are possible if you whichever way you want to sort of do this. The last one, before I jump to quickly multimodal live API, is the code execution. So just like the tools, and this is again the biggest theme of Gemini 2.0, that now you have many tools available as agentic tools, and this one is the code execution. So rather than getting the code, if you were to ask a question saying, hey, calculate the 20th Fibonacci number, and you can see that I'm defining the code execution tool, you can see it actually now executes what you have asked, writes the code, checks the output, and actually gives you the final answer rather than the code that you're asking for, right? So this is brilliant. Like, there are some times you're trying to do mathematical computations during when you're trying to ask a prompt. You can actually just use a code tool, and that code tool will just do the calculation and give the answers to you, right? So with this, I'm going to sort of quickly stop and move to the next one, which is one of the very widely sort of, this is one of the biggest um, thing which people loved in our launch, which is the multimodal live API. Again, if you've seen some of the demos people are building with this, you will be very happy and surprised to learn how to do this. So what I'm going to do quickly is, again, I'm going to share the link with all of you about this notebook, so that you know what I'm walking through. And I'm not going to talk about all the initial setup because that remains exactly the same, so you're still using the same unified SDK. All I'm going to show you is that how does this actually function. So this uses WebSocket. So of course, notebooks are not the right way to show a live API demo, because notebooks are not meant to do these live interaction, right? So bear with me. This is just an example of how you can actually use that API. You would of course put this inside, let's say, a web interface or some kind of a thing in the back. But let's say if you were to do this, this is one of the examples where I'm showing you where the input was text and the output was text. So you can actually do text to text stream as well. The one which I love is the text to audio. So if you have a text which is, hello Gemini, are you there? So you can see that I'm explicitly mentioning this, and it actually gives me the output in audio. I'm not sure if you were able to hear this, but anyway, when you run this at your end, you should be able to see the audio that comes out of it. And that's exactly what you would do in your application at your end, where whatever user says, it'll sort of directly streams back the answer using the WebSocket. And the last one is something where, let's see if I can run this. So I can say, hey, how are you? You can that it actually streamed back using the WebSocket the answer to this, and I can ask, and I can keep continuing to talk about this, right? I can say, how does sky, or let's say, why is sky blue? Why is sky blue? And you can see that it'll again go back as a stream. It'll try to generate the answer, and again, so you can see that it responded, and you can keep continue to do this, or you can just exit this loop by writing a queue. Again, the codes are here. We have given you many different examples of replicating this at your end. With this, I'm going to stop. And I've shared all the codes that are possible. In fact, I'm going to share the main repository where you'll actually find all the different things available for Gemini 2.0. Make sure that you check this out. It has many, many different other examples of cloud in general. So make sure that you give it a time. With that, I'll stop. Let's take questions. All right, let me take the questions from the bottom and then I'll go up. That way it will be quicker. So Anna has a question. What best practices do you recommend for developers new to building application with Gemini? That's a very interesting question. So what I would say, and I have been at that place, Anna. So it's not like, we knew everything and we were building everything perfectly from day one. What I would say is that, and this applies to everyone, be it somebody who's starting, or be it somebody who has done so many things, is do not focus too much on sort of building the perfect things from day one. Try experimenting with codes that you have. Try coming up with an idea. What I usually do is the fact that I come up with one idea a week, and then I use all these SDKs to build that idea. And of course, I do research and figure out how to do that. But this is what, I always keep in mind. Now, coming to the best practices, again, you should follow the same standard coding best practices, that everything should be functional, functional as in everything should have a function and all of that, your variable names and all of those things. But again, make sure that you're experimenting. It's absolutely fine if you are not writing the best versions of the code, as long as you're able to solve the problem that you had in your mind. So make sure that you're building things every week, rather than just reading, or just thinking to do something. That's what I would say. Let me know, Anna, if that sort of answers your questions. If not, you can just ask a follow up. Ming has a question. No questions are stupid, Ming. So code execution occurs on my side or on the cloud? It happens on the cloud. So the code execution is attached to the model. So the code execution is happening in the cloud, not on your side. Ming, with complex schema, can I just pass the top level pedantic object and Google AI package figure out recursively the nested false structure? I think instructor does that. Yes. Sorry. Yes, I mean, yes, instructor does that, but that's not something GenAI SDK will be able to do right now. We don't have that feature. So you would have to build an agent or some kind of a layer to do that, or maybe integrate that with instructor. With multimodal prompt, do we support multi-turn chat? Yes, I showed an example of that. Just to quickly again show you that you can actually do a multi-turn chat. This is the example that I showed. I hope that answers. If you can share what upcoming features can we expect in future iterations of Vertex Gemini. Of course, I won't be able to share that. All I can say is that the link of the repository that I shared, so this one, the last link that I shared, please make sure that you keep on checking this, because whenever there is an update that happens, so if you notice the top, this is all the new things that has happened and the associative notebook slash assets around it. So it's not just the intro notebooks. You can see that we actually have 3 very advanced notebooks as well, which are using Flash 2.0. So just have a look into this, and you'll see everything that we are launching and that is available for developers to work on. And are there any specific tools or libraries you recommend using alongside Gemini to validate or transform the structured outputs? That's a very interesting question. So, what I can say is that, of course, you should have a test function associated with this. So, one of the good practices that I have noticed, and I have done it sometimes, is the fact that even if I do give a structure to a model, I always have a test function that takes the output and runs those specific tests. Now, those tests is something that you can also use Gemini to write for you, including the edge cases and all, to make sure that Gemini is not returning anything which it has not, which you're not expecting. So, I am not aware of any internal tool that does that for you automatically. So, my only suggestion there would be to sort of write a test cases for the generation that you have. How do I set up multiple JSON schemas for response to multiple function calls? You would have to set them up all separately. So, for example, if you, and please correct me if I'm wrong, maybe I might misunderstand your question. What you're saying is that I have multiple schemas and I want to make multiple different calls. Um, or again, I'm sorry, I'm confused with your question. Is your question that can I send multiple schemas to one single prompt? Because if you're sending this to multiple thing, you can actually you would have to make multiple calls. So You can't do this in a single call. So you would have to have multiple JSON schemas, and then you would have to define multiple function prompts in that. Okay, what are the limitations and potential challenges of function calling? Oh, very interesting. So, one thing, function calling, as the name suggests, is not exactly calling the function. These are all sort of signatures that you're sort of preparing, except one where you're actually just passing the whole as a tool, which means your function has all the interface of the execution embedded into that. So, that's something to be aware of. The limitation, of course, is that if the model for whatever reason doesn't understand what needs to be passed as the parameters of the function that is executing, it may fall, or let's say the whole logic will fail. So you need to have proper testing frameworks around those, so that if anything that happens in between which is not supposed to happen, you catch them early, and there's a recursive process that you have written. So there's no recursive process, which somebody did ask this. So there's no recursive process internally in the function calling where it sort of retries that. So you would have to do this again. So you can actually define either a lang graph. So you can use something like a lang graph to define a graph structure which can process again and again until it gets to the point that you have. Or you can define this on your own, saying, hey, this is what I want. If you fail in between, rerun this whole one more time by adding this. All right, I think I did answer all the question. So Ming has a follow-up. I mean, with video image prompts, say I add a prompt of video which can be quite large. Can I have multiple turn question? Oh, I see what you mean. Yeah. I think multi-turn is not supported in that. You're absolutely right. The way I've seen that, Ming, is people actually chunk that. So if you have, let's say, multiple questions on a 10-hour video for that, for instance, let's take that as an example. You'll not be able to do this with multi-turn because you'll anyway hit up the limits and the quotas and everything. The way you would want to do this is you want to develop a proper RAG system where you chunk these videos. For each chunk, you define what's happening in those chunks through Gemini. You store that, and then you build a RAG layer over it, so that you can do more back and forth with that. There's no direct way to do that if it crosses the limits that we have in the system right now. Does that answer your question, Ming? The straightforward answer is that you need a RAG layer to do that. If that's what your aim is, to ask to do multi-turn with this.